7-Eleven. No, not the gas station. I know, Leland, you're excited because you just got a 7-Eleven not too long ago. And if I'm saying that, that's probably going to date to this video in some form or fashion. But 7-Eleven is actually the general chapter that Dissolution comes from. So we're going to be talking and we're going to be focusing on 7-Eleven general chapter Dissolution. But at the same time, this also has disintegration that can come along with it. And we're not really going to be focused in disintegration because disintegration was CTC 114. And again, if you paid attention and if you watched the videos back into that class, if you've taken that class already, then you should know what disintegration is. But that is not our focus today, nor it's our focus in another day on another video. It is all about dissolution. That is where we're going to stay. So Dissolution, 7-Eleven, general chapter, and I need to take a whole lot of minutes in order to go through this entire process with you. All right, so here is General Chapter 7-Eleven from the USPNF, the United States Pharmacopoeia National Formulary, or Pharmacopoeia National Formulary, tomato, you know what I do. All right, so 7-Eleven Dissolution, it says, General Chapter Dissolution 7-Eleven is being harmonized with the corresponding text of the European Pharmacopoeia and or the Japanese Pharmacopoeia. That is also known as EP or JP, folks. These pharmacopoeias have undertaken to not make any unilateral change to this harmonized chapter. What this means is that people were getting tired of following rules mandated by the United States version, and then following different rules for the European version, and following maybe different rules for the Japanese version. And these are some of the largest pharmacopoeias that are out there that people follow. So all three of these groups came together and they did harmonize, and they kind of talked to each other and they were like, listen, let's kind of make some rules that all of us are okay with. And if we're okay with it, you can be okay with it. And that way, this test can be performed the same way, no matter kind of the realm of the pharmacopoeias that we are working within. Portions of the present general chapter text that are national USP, so United States only, and therefore not part of the harmonized text, are marked with little asterisks and a little subscript that happen down below. So they were letting you know, listen, we tried our best. Most of this is going to be kind of jiving with these other countries, but there are a few things that we do a little bit different, and we're not going to get away from that. And those things in particular that are United States directive are going to be kind of isolated and known and flagged, and that is their way that they're going to do it. This test is provided to determine compliance with the dissolution requirements where stated in the individual monograph for dosage forms administered orally. So that means going into this particular type of test, whatever this test is, because I've not really showed you what it is yet, but going into this test, it really is going to be focused on oral content. That is what we're after. So that basically means some type of tablet, some type of capsule that I'm going to have to swallow with maybe a glass of water or something like that. This is not going to be liquid forms because they're already undergoing dissolution because they're liquid. They're already in solution. That doesn't make sense. So oral suspension or oral tablets and capsules only. In this general chapter, a dosage unit is defined as one tablet or one capsule or the amount specified of the types of apparatus designs described herein. Use the one specified in the individual monograph. All right, so that means that there's going to be different apparatuses for me to choose from. Yeah, there is, and the monographs will tell us which one to use. So it's going to be my job to kind of tell you what is out there so we'll know kind of what's going on. Next up, it says, where the label states that an article is enteric coated and a dissolution or disintegration test does not specifically state that it is to be applied or delayed release articles and is included in the individual monograph, the procedure and interpretation given for the delayed release dosage forms are applied unless otherwise specified in the individual monograph. Okay, so what is enteric coated? That's something else that we need to know, because that's maybe a new word, a new definition that we need to learn a little bit more about if we're going to kind of dance in this little little pharma party that we call quality control. So before we go any further, I want to kind of talk about the difference between tablets and capsules, because in this introductory paragraph of dissolution, and again, what is dissolution? I don't know what it looks like because he's not told me, but it at least mentioned a capsule and a tablet. So here is a picture of a tablet, and a tablet is just kind of a solid dose form where that solid dose is pressed into a tablet, and there are binders that kind of help hold all of that tablet together, and they can also flavor these tablets, and they can put colorants or dyes into these tablets. They can do whatever they want to do with them, but that is form of a tablet. So typically what you would see here is something like an aspirin medication that is a tablet form. So if you just swallow that down the hatch, we're going to think that it breaks up. At least I hope it breaks up into my little tummy. And no one will be the wiser if it doesn't. But we at least assume a couple of things. And that is one of the assumptions, that it does break apart and break down once we swallow it. So that is a tablet, and a tablet is a very common form of oral dose medication. And that's what this dissolution test is going to focus on. And the other version is called a capsule. And here is a capsule. And a capsule is basically, and we'll talk more about this a little bit later, but a capsule is basically this type of, you would regard it maybe as a plastic coating, and this plastic coating can come apart, and you can pull the two halves apart from each other, and there are contents on the center of that tablet that can just free fall out because it's not packed, it's not bound together in any form or fashion. So typically a little bit of loose powder on the inside of these capsules, and they are surrounded by a capsule or some type of material that's going to keep them intact. So that way the capsule is going to break apart, dissolve, or get destroyed in some form or fashion inside of your stomach, or maybe a little bit later on after your stomach and maybe into your intestines, where the solid dose is going to get absorbed. There's some other different types of medications that you're seeing on here, everything from meltlets to caplets to soft gels and effervescent tablets. And effervescent tablets mean that just means bubble, 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 bubble. So these are going to be tablets that you can dunk into a glass of water, and you will start to see them fizz, and you will start to see them bubble based on the typically CO2 release, carbon dioxide, that these things are given off. Not every time, but it's one of the things that does happen with the effervescence tablets. All right, so this is our focus. Let's say that we get a finished product, and that finished product is going to be in one of the two forms of medications, either a tablet or a capsule. And there's going to be tests that I'm going to have to do on these finished products, whether they are tablets or capsules. And dissolution is going to be one of those common tests that come along with these types of finished products. So what is dissolution? What is 7-Eleven? Ta-da! Here we go. So 7-Eleven is dissolution, and it's really focused on this idea that we've got a contraption, and this contraption's got some vessels, and in the vessels we have some liquid solutions, and these liquid solutions maybe could be water, maybe they're not, but it is a liquid solution that is poured into these vessels, and that is supposed to represent, almost in a way, my stomach. So the milliliters very often are 900 milliliters in total volume, but they do not have to be 900 milliliters in total volume. There are monographs that are out there that do 500s instead of 900s and so forth. So it just really depends on the specific solid dose that we are working with. But I would say that 900 milliliters is pretty run-of-the-mill. I mean, that's what we see most often. It's very commonplace in a dissolution test. And it can just be water. I mean, that's all that it can be. And that liquid that gets poured inside of those vessels, that is what we call our medium. So medium gets poured inside of the dissolution vessels, and typically 900 mils of medium is used for this process to kind of start initiating and get ready for us. Again, though, it is not water every single time. And if it's not water, don't be surprised if it could be something like an acid, like hydrochloric acid. I mean, very often hydrochloric acid is in our stomach, right? So very often when I see something that's not water-based, then hydrochloric acid could be a substitute or could be a reagent for our medium that we would need, and a very weak solution of hydrochloric acid maybe. And then the other option that we really see too is buffers. And buffers really purpose is a pH controller. So I can kind of control the pH of this medium by using different recipes of buffers, whether it's pH of 6 or pH of 6.4 or pH of 7 or 7.4 or 7.8 or 7.6. You get the picture. These buffers help me control that pH quite nicely. So the buffer recipes can be given, the acid recipes would be given, but I hope, cross my fingers, it's just water, because there's nothing that I need to prep. If it is water, I just get deionized water or distilled water out of our faucets and sprayers, and I just go to town in the dissolution systems. What will happen is that once I get this vessel filled with our medium, then we get a little solid dose form or tablet that drops down on the inside of these vessels. That solid dose form, again, it could be a capsule or it could be a tablet most of the time. These solid dose forms hopefully will sink to the bottom, and we'll talk about what would we do if they don't sink. But we hope that it goes down to the bottom of the dissolution vessel, and then it just kind of sits there. And then we introduce one of two things. And the first is going to be what you see in the picture, a paddle, or another one is a basket form. So 1 and 2, but let me not number them that way. I'll just do A and B. I don't want to get you confused. So I get two different options of attachments that I can place inside of our dissolution system. A paddle is one option, and a basket is another option. I would say that out of these two different options that we use dissolution for, we often, in our program at least, see paddles more often than baskets. So very often we're using paddles. We're going to do multiple dissolution tests over the course of the 2-year program. If you've taken 114, you've already did a dissolution. That was with a paddle. Some of the upcoming dissolutions that you're going to see in this course are going to be paddles. And many of the ones that you're going to see after the fact in other courses in the future are also going to be using paddles. And it's just something that we just don't really get away from. It is one of the more common ones that we see as a program, but probably also real life apparatus with the paddle. Next up, those paddles or those baskets, they have to rotate people, they have to spin. So that's part of the dissolution system. We want a motor up here at the very top, and that motor will turn, and that RPM is going to go around and around and around and around and around and around and around. RPM is rotations per minute, and these rotations per minute will change depending on the solid dose that we are working with. So for instance, our settings could be 50 rotations per minute, 75 rotations per minute. It could be 100 rotations per minute. Whatever the case is, it's going to be listed in the monograph for us to follow. And that is a setting that I'm going to have to make on the instrument or the software that operates the instrument, so that way it knows how fast to turn these paddles or to turn the baskets that we are using in the dissolution setup. Finally, time is also going to be important. So in the monograph, time is typically going to be given in minutes, and it will tell me once you drop the tablet and once this process starts, you want to continue this process of turn for 30 minutes or 45 minutes or 60 minutes, or it could be hours depending on the solid dose form that we've got. But very often the term or the unit is at least in minutes, because these are typically between 30 minutes to 60 minutes on what we see within our program. And again, that's not necessarily true to real life, but everything that we do, we've got a controlled time that we have to start something and end something, and we're not going to pick dissolutions that's going to take hours of runtime. Even though real life and work can actually do that, we cannot, because we have limited time in the lab. Boo-hoo-hoo! I know you want to spend more time with me. So the RPM and the time will be set by the user. Again, that's either on a touchpad up here at the very top, or it can be driven with software depending on how fancy of a dissolution system that you've got, but you have to key in those settings at least on the equipment. Otherwise, it's too stupid to know what you want to do. So you've got to at least tell it. And I like telling things what to do, right? And I know you do too. Listen, Dissolution, I'm tired of you sitting on this countertop and not doing anything the right way. And I'm going to make you turn at 50 RPM. How do you like that, Dissolution? Take that, 7-Eleven. I've got the power in the lab. All right, so monograph again. I've talked. These settings are in the monograph. Settings are in the monograph. Medium will be given in the monograph. The time will be given in the monograph. The RPM will be given in the monograph. All right, so those monographs are going to easily be found, and you've probably already done many of them maybe at this point, but these monographs are going to be found in the USPNF or the other pharmacopoeia or pharmacopoeia methods that you are using in the laboratory environment. Here's a picture, another dissolution systems up here at the top. And what you're finding is a little bit different type of model. These dissolution systems are manufactured by many different companies, and they all come with little perks or things that make them slightly different. This one that you're seeing here, this is an Agilent dissolution system, and there's some tubing lines in here that you're not really seeing on our equipment, and I'll talk about what that's going to be doing here in just a minute. And then here you often also see, hey, here's some baskets instead of paddles. So that's what the baskets look like. But the other reason that I like this picture is up here at the very top. It gives you an idea of what some of those tubing lines were in the Agilent system that you saw before. So up here at the very top, you're seeing syringes, and those syringes look like they are connected to some type of piece that goes into the top of the system. But if you look down, whoa, look at there. All right, so what this is a very convenient way to pull samples. So these are cannulas, they are extended cannulas, and what's happening is that little probe is going to get dunked down into that solution that has your medium, that has the capsule, or that has the tablet that's getting dissolved, and that will provide a very easy way for you just to grab the syringe and pull back. And that allows you to take a sample pull that we call an aliquot. That is the proper name of that. So we are going to take an aliquot of sample, and that aliquot of sample can be reserved and saved for future tests, because probably we need to know how much of that active ingredient has been released and is now in solution. So we're going to have to do future tests on it. Whatever future test that is, that's for a different time and a different story. But now we're focused on dissolution, and we need to just look at this dissolution equipment and talk about kind of the little ins and outs of how to use these and what to watch out for. So there are some models, like some of these Agilent systems, that can automatically do sample pulls for you. You don't even need to pull back on syringes. It will do that on its own, and it will also squirt them down into some sample chambers and put lids on them, so that way you don't have to do anything at all either. You can just kind of walk away, let the system take over, let the system do the sample pulls, let the system squirt it into some sample containers that it can put a lid on. It can filter them for you as well. I mean, there's like almost no touching involved with dissolution nowadays. And it just really depends on the manufacturer of the dissolution system and the make and model number that you want. The monographs, you're going to find them typically under what we call performance test of the monograph. So performance tests are typically given to capsules and tablets and some of these solid dosage forms. And this is going to be embedded into a typical monograph that you've always seen, that you probably have always done up until this moment. And it's just an extra little piece that will go in and talk about some of the extra tests that we can do on these finished types of products. So here I see disintegration and dissolution. And here, though, it says 2040, not 7-Eleven. Oh, no, he's lied to me. Why is it 2040 and not 7-Eleven? Because I just thought he told me 7-Eleven gas station. Yeah, that's true. So 7-Eleven is actually going to be reserved for what we would call the over-the-counter drugs or prescription medications. So this is what I would call the normal version of dissolution. So if a doctor is prescribing these medications, or if you're going to the pharmacy and you are in that area that's selling some of the over-the-counter drugs like the aspirins and the ibuprofens, some of the Aleve, all of those types of medications, those are going to be under 7-Eleven. However, 2040 is going to be another version of dissolution and disintegration. And this is really in reference to the dietary supplement world. So these dietary supplements are going to be all of your vitamins, vitamin A, vitamin B, vitamin C, vitamin D, all of those ginsengs and ginkgo biloba and glucosamines, all of those are going to be under dietary supplements as well. Your multivitamins, of course, are going to be under dietary supplements. So these are things that are really taken to supplement your dietary intake. They are not claiming that they are helping you do anything at all. They are just simply there because they believe that you think you might need more vitamin C in your dietary intake because you don't drink enough orange juice. So you go to the vitamin C and you grab them and you swallow them down the hatch, and then it's not claiming that it's going to help you do anything. It's not claiming that it's going to help you fix a problem. It is just a dietary supplement that you are taking because you think that you want it or you think that you need it. So they fall under a different category in disintegration and dissolution, and that is 2040, not 7-Eleven. So 7-Eleven is going to be the normal prescription drugs and over-the-counter drugs that you are taking to help prevent or help a problem to go away. So here we see medium, and for this one, woo, thank goodness, water at 900 mils. And then we see apparatus number 2. Well, what is apparatus number 2? We're going to talk about that. And it says here 75 RPM. So that's where I'm going to get that setting. Next, it says time. Time is 60 minutes. So that's where I'm going to get that setting. So all of these directions are going to be given in the monographs depending on the solid dose that we are working with. Whether that is over the counter, whether that's prescription, or whether that's dietary supplements. All of those settings are going to be given to us in the monograph pieces once we pull them. The analysis says, proceed as directed in method 1 or method 2 for strength, making any necessary volumetric adjustments. Okay, well, whatever that means, who knows? We're not talking about that yet. And then the sample solution. If method 1 is used, pipette 10 mils of the filtered pooled solution. A lot of people skip over this because they think the pooled solution is actually this swimming pool of medium. And that is a no. That is not what pooled means. So this medium is in one dissolution vessel that represents one dose. Pooled means something completely different, and we'll talk about that a little bit later as well, but that's the reason that I snapshotted this particular type of monograph, because it does say pooled solution. Under the test, a 50 ml volumetric flask and dilute with 2% nitric acid to 50 mils. If method 2 is used, dilute the filtered pooled solution under the test with 0.125 normal HCl to a concentration falling within the range of the standard solutions. So it looks like I get two options, whatever those options are. I don't know that yet, but it looks like I get two options here under the sample analysis piece, but both of them are referring to a pooled sample or a pooled solution, and that does not represent one dissolution vessel. So again, we'll talk about that a little bit later on, but it's something that I can at least bring to your attention right now. Otherwise, though, settings for the dissolution are going to always be provided. Here are the baskets and here are the paddles, folks. So over here to the right-hand side, this is our basket. It looks like a little woven basket. Oh, somebody probably was in a lab and wove that little stainless steel basket just for my little capsule. How sweet and nice and generous. And then over here is going to be a paddle, and that paddle is going to turn, and that basket's going to turn, and it's going to put some motion in the ocean of the medium of the dissolution vessel. And the other thing that I want you to focus on in the image, or the images that you're seeing here, is where we're going to eventually pull the samples from in a dissolution test. So here you're going to see a big circle, and that big circle says A. And notice that they are positioning A at a certain point. And if you look at the top of this liquid solution, and if you look at kind of where this paddle is located, that A is sandwiched almost right in the middle of those two areas. And that is the proper sample pull that we will be doing from the dissolution system. So at the very end of my time, I'm going to go over to the dissolution systems. And if I've got to manually do this, I'm going to take a syringe with something called a cannula, and that cannula is going to be lowered down into my dissolution vessel, and I want it to kind of hit somewhere in the middle. I do not want to go all the way down and pull from here. I also don't want to just break the surface and pull from the top. That is not appropriate, and they do not tell you to do that in the USPNF or any of the pharmacopoeias for that matter. So because of that, we always kind of hit to the middle, and we want really close to the stem of the paddle or the stem of the basket. In other words, I want to get away from the edges of the dissolution vessel. So it needs to go inward a little bit more. Don't go to the edge of the vessels, but also don't go all the way to the edge of the stem of the paddle and the basket either. But you want somewhere in the middle, somewhere close, and again, in between the top and the paddle or the basket top. So somewhere where they have listed A. Dissolutions. There are two types of dissolutions that we're going to see in a laboratory environment. The first type are the ones that we prefer, and that's because they are typically one shots, one pulls. That's all I get. So I get my one syringe and my 60 minutes is up, and I run over to the dissolution as fast as I can run because I don't want to violate the method because I broke the time interval. And then I'm over at the dissolution and I put my syringe and my cannula down on the inside, and I take an aliquot of that sample and I just pull out, and then I've got it in my syringe, and then I filter it. So those are one-shot pulls. Those one shots will be analyzed on a different machine at another point in time, but those are one pulls, and it makes my life much, much easier. The other version of a dissolution system, though, is a kinetic study. Ooh. Kinetic studies mean over a time interval. Oh no, what are you saying? That means that a kinetic study is going to be done over a course of time, and there are going to be multiple pulls that will happen throughout that time period. And you could have 3 pulls, you could have 5 pulls, you could have 10 pulls, you could have, these are aliquots by the way, 3 aliquots, 5 aliquots, 10 aliquots, 20 aliquots, 2 aliquots, 4, 6, 8, who do we appreciate? Aliquots. So the more of them, though, the more that you're going to have to test, the more math, the more equation, the more spreadsheet, the nastier it's going to look. But this is a thing because kinetic studies are really all about how long. How long does it take that solid dose to fully break up and release all of that active ingredient, or as much as possible of that active ingredient, into the solution? Does it take 10 minutes? Does it take 1 hour? Does it take 2 hours? That is what a kinetic study is going to help us to determine, and that's why we take multiple pulls over a course of an extended period of time. All right, so here's basically an example of why kinetics are going to be important and why we like to report on these sometimes and why some of the testing is done on them at times. So in this pretty little graph, you're seeing a blue line, and the blue line, pew, goes straight up. Oh, whoa, right? And that blue line is an uncoded tablet, and that uncoded tablet basically means that it is a tablet that is just general, run-of-the-mill, no bells, no whistles. They just crammed something into a little pellet, and I'm just going to swallow it down and not question anything about it at all. So that is a uncoded tablet. And the uncoded tablets, it's going to break up, and it's going to break up typically a little bit faster, and it's just going to release everything that's in that tablet, and these things typically happen very quick. So if you take a look at the x-axis here is in units of time, but that unit is hour in this graph, in this example, right? So here we have 1 hour and 2 hours and 3 hours and 4 hours and 5 hours. And if I take a look at this blue line, I'm going to see it go up, 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 up. That means it's releasing active ingredient. So it's released a whole lot of within a few minutes probably of the dunk, but it keeps releasing all the way up to about 1 hour. And then a little after 1 hour, it begins to flatline. And the reason is because at this moment, all of the active ingredient from that tablet or that capsule has now been released. There's nothing else for me to left. There's nothing else left for it to release because it's already gotten rid of all of it. And we see a flat area of the graph because of that. On the red line, though, that red line's a little different. So the red line is something called a film coated. So this is a tablet, and they might not necessarily want that tablet to break apart all at one time. They want this tablet to take its time, get used to the jacuzzi, turn the love music on, get those glasses of wine in that dissolution vessel, and these tablets are going to take their measly little time to start breaking up one by one. So what we often see is a very slowed or delayed release because of that. So that protective coating allows that tablet to stay a little bit longer in the medium before it starts to break down. But in the beginning, if you look, we start to see an increase of the release of the active pharmaceutical ingredient. So keep in mind, active pharmaceutical ingredient is abbreviated as an API, the active pharma ingredient. So that API is going to get released in the dissolution vessel, and it's going to increase like normal, like all the tablets are doing. And then sooner or later, it also begins to flatline. So after a certain point in time, that line really does not increase anymore. And that's because all of the API has now been released. There's nothing else left to go into solution. It already has went in solution. And if you look at this particular type of tablet, these are the same tablets, by the way. These same tablets are just manufactured in a different way. And this particular tablet that has the film coat on the outside is going to take a little over 3 hours before that thing starts to flatline and plateau on us. So it gives people control of how the medication is going to behave once you take it. Do they want the API to instantly get released, or do they want the API to take its time and slowly release over a course of a few hours instead of a few minutes? So the coatings are going to affect these tablets. The binders that they are using that keeps it all together will affect it. And the formulation, the way that they have made these things, are going to affect this as well. And sometimes we want that extended, and sometimes we don't. So that just really depends on the company, the manufacturer, the intention of the medication. That is what all of that is going to refer to. Finally, how much, right? So if the objective here is to use a piece of equipment that looks like this, and a solid dose gets dunked on the inside, and it starts to break up and it starts to get released, like, what do we do with it? We're not just simply looking at observations, right? These dissolution systems are going to require quantification. So observation is a part of it. I noticed that my tablet did not break apart after the time interval. I noticed that my tablet broke apart within 2 minutes after I dunked it down into the medium and the dissolution vessel. These observations are very important, and I don't want you to think otherwise. But at the same time, dissolution goes above and beyond. It goes further than that. And quantification is going to be a thing with dissolution, and that means numbers. We're after numbers here. And those numbers are the milligrams of the API that tablet or capsule had, that tablet or capsule released. That is the purpose of the dissolution system. So in other words, if we've got a medication that says 220 milligrams per tablet, if I put that tablet in the dissolution system, great, it broke up. I see it. It turned the medium color and it broke up and it fell apart. Whoa, great. But what does that even mean? I mean, if I don't do quantitative work, if I don't tell you exactly how much API was released in that medium, then what's the purpose of doing the test? There isn't one. So what we're after is we're looking for, does it really have 220? And there's some math work that goes along with helping prove if it has 220, or maybe something way less, or maybe something more. But most of the time it's going to be way less, because I don't think that a company is going to cram API into a tablet and give you more than what's called for on the tablet. I mean, there could be. I'm not saying never, but most of the time it's going to be lower, not higher. So in order to do the quantitative work, and again, that's not really the purpose of right now, but the quantitative work is going to have to come with the help of additional equipment. And here are 3 areas that we use for dissolution runs. These are not the only thing, though. I want you to understand that. But these are 3 of the more common ones that we see in our program and that we see with general run-of-the-mill tablet identification and quantification. And these are going to include atomic absorption, that we abbreviate as AA. Atomic absorption does really great with metals. So metals would be things like zinc and chromium. Those are going to be dietary supplements that you're going to find out on the consumer shelves. And atomic absorption does a really good job with anything that's classified as a metal. The HPLC equipment, high performance liquid chromatography. These are really going to be the workhorse of the dissolution system. We are going to find very commonly HPLC that's going to be used at the end of these dissolution runs. The HPLC equipment is great because the HPLC equipment separates, and that is part of what we want it to do, because we want that kind of active ingredient separated from all the other crap that could be there in the tablet. But it also quantifies. So not only does it separate, but it also will help me determine how much of that API is actually there in the sample that I pulled and in the sample that I ran and analyzed. Next up, if there's not too many interferences, or if there's not too many other ingredients in the tablets, and they know this because of the manufacturing, then you could get by with just UV vis. And this is something that we will see as well in the program. We'll take an aliquot from the dissolution systems. We might dilute it, we might not have to. That just depends on the day, the tablet. And then we will analyze those aliquots on just a simple UV vis instrument. Nothing needed, just add it into the cuvette, run it, get some numbers, and then quantify that way. So all of those are fair game, but typically something has to be used other than dissolution. So it's going to be a dissolution focus, folks. 7-Eleven, that's where we're going to be at. And that dissolution will also be paired with, who knows? And that's the purpose of some of our other courses, to talk about how the equipment works, the pieces and parts that make it do its job, and why we would use HPLC or AA or UV or some of the other instrumentation in a laboratory setting. But here it's just simply dissolution, and that's where we're going to stay. And we're going to play that game for a little bit. All right, so 7-Eleven dissolution. Here's the document, and we've got through the first paragraph. And in the next video, we'll make it through the next 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pages! Yeah!